By the way, I want to show something we need to modify quickly because things are changing. So we are back on our design so we can review what we were doing and update our design as supposed to. To update our design, things has changed. As you can see, the interface is no longer named Authorization. We name our interface to mobile payment, and we have the client's ID and the token, which are universal properties that each subclass has to implement or inherit from the abstract class. On M-PSA, we have the API key and we have the session key. We also have, as it turns out, we also have the encrypt. We could alternate the token to receive both the session key or the encrypted key, but I think the session key is separate from the token. So we have the API key, we have the session key, and we also have the public key. Public key, and that's for a mobile service or the mobile financial service, as they call it, the MFS mobile financial service. We have the public key, we have the API key, the session key. That's for M-PSA. For Airtel Money, we have this client's secrets, and we have the client's ID. This one has to be removed. The API key is the client's ID. Okay, the client's ID or the API key are the same. I don't, even if they're using different concepts, but when we are integrating, we can also change, we can also merge terminology as we are integrating that. Yeah, now let's go make some payments on M-PSA. We need to make some payments. Okay, so to do that, we are going to encrypt the session key. So to encrypt the session key, we already have the session key. We are going to use a URL, a specific URL to encrypt the session key. What is the URL we need to use? The URL we are going to use, it's gonna be this URL. Let me show you the URL we need to use. To encrypt the session key, we're gonna use this URL. Let's go to the API documentation, generate session key. Okay, so this is the API, this is the URL that we need to use to encrypt the session key. And you can see we have to replace the markets to the markets where our application has been created, and they have different market options here: Tanzania, Ghana, Lesotho, and this beautiful country here, this country, and of course Mozambique. We have to, let's go back and try to encrypt the session key quickly before we run out of time. So the URL we'll be using is the URL, the sandbox IPG. So let's pass our URL, https open api.mpesa.com/sandbox/IPG/v2. Now the markets, we need to replace the markets. The market's gonna be the country where the application has been registered, and our markets will be Vodacom DRC get session / that will be our URL. Now we need to issue the HTTP request. My clients of choice, I'm going to import the HTTPS, which is the request wrapper. It's built on top of the request module from Python that can be used as a client's HTTP to issue request. Okay. With HTTPX clients, we need to build clients. We are using the Python context manager. For those of you who do not know the Python context manager, it's just a syntactic sugar or an idiomatic way of using the try and catch, which facilitates for your piece of code to fail gracefully. Okay, so with httpx.client as client, we have to create our response client get. We are going to get the URL, the header. We need to pass on the header. We have to pass the token. Actually, this one is the token self. Okay, so the header is gonna be, we already have our header as a default header. We have our default header right here. Content type, the content type in this case, I know the content type, it's a little bit complicated to know if the content type is representational or the content type define what you'll be expecting from the server. We really don't know. But in this case, I think you cannot send a text and expect the XML, or you cannot send a file, expect a text. It might be possible, but the content type in this case is a representational or header, just telling the application, hey, I'm gonna send you the JSON. But at the same time, it's also expecting a JSON response, right? You cannot say the content type application JSON and expect XML, unless you are building a secure application where you don't want to know what you'll be expecting. It depends on the implementation. Okay, so we have our headers right here, and then we go down, we're gonna update. If we go right here, we can update our headers, add a new feed in our dictionary. That feed will be authorization. We pass the bearer and we pass the token, and the header will be update self header. That's our token. Now the encrypt session, the result of this response will be our the session key. Okay, so self session key equal to response JSON. Let's see how we're gonna get that. Let's try this. So we have our M-PSA. Let's encrypt the client's ID, and let's try to print the M-PSA token so we can see if we're gonna get the token. right here after encrypting the client ID. To do that, we can try something like this: share payments M-PSA. Of course, I'm not gonna use that like a Python script. I'm using that like a Python script here so you can see the way it can be used when I will integrate that in my Django project. It's gonna be couple line within a REST API endpoint or the Django API view. So we're gonna, when the user send the record, we gonna authenticate them, redirect them to or M-PSA, make sure that they exist, and proceed from there. But for the sake of this video, I'm using a Python script so I can demonstrate what we are getting from creating these methods. What else do we need? So we've created our session. It looks like we can get the token, and then we're gonna use that token here to get the session key. So we create the token using the API key and the public key. We use the public key to encrypt the API key. It returns a token. We use the token to get the session key. And now we're gonna encrypt the session key so we can start making payments. So the response, now let's see the way we can get the session key. If we call M-PSA object and say encrypt session key, we have not encrypted yet, so we're just gonna return the session key right here. We're just gonna return the response right here. And then we print session key. There we go. So we got our session key. This is our session key. And this is the session key we need to encrypt so we can start making payments. Payments between a customer and a business, where a customer buys something. Okay, so we're gonna grab this output session ID. We're gonna grab it. And now we need to encrypt it. We cannot encrypt it as a string. We need to convert that to a byte string. But we are going to encode that using ASCII. We're gonna use ASCII encoding. We're gonna use our famous create bearer token, which allow us to encrypt a string using a public key. So what we're gonna do on the next step, we're gonna update the token. Now the token is now updated. We could name this encrypted session key, but we're just gonna pass it back to the token. Why we're using the token? Because the token is the one we're going to pass on our header, authorization header. Token self create bearer token. What are we gonna pass on the bearer token? Self session key. The results will be, if we, instead of sending, if we want to print the token right here, you will notice that the token will be a byte string. It's not gonna be a string, it's gonna be a byte string. And when I'm talking about a byte string, it's in the computer science, byte string. It's not like a byting a string. Okay, let's go test that. As you can see, this is our encrypted session key, and this is the new token that we'll be using to make a payment.